Here we are back at our circuit simulator. I have the single bulb circuit moved over and in operation already that we've already seen. I want to take and make a couple of measurements. The first measurement I want to use is this non-contact ammeter. An ammeter allows you to determine what the current is in a system. In reality, non-contact ones don't work, but for the sake of this, it makes life very nice. So in our single bulb circuit, before the light bulb, we have 0.9 amps, and after the light bulb, we still have 0.9 amps, as we expected, because the electrons are moving everywhere, if you will, there. I'm going to just move my non-contact ammeter down there and pull out a voltmeter, which allows me to measure the voltage used or given by circuit elements. And I do that by just putting over the ends where I want to measure. So the battery in this case is a 9-volt battery. And if I go up to the bulb, we see that it uses 9 volts, or roughly 9 volts. So current is not used up by the circuit, but the energy supplied by the battery has to be used up in the circuit, primarily in this case at the light bulb. Now let's take what we just saw with the single bulb circuit and look at two bulbs in series. So let's wire up our bulbs in series. Here are my two bulbs. To put them in series, I wire one end of one to the other end of the other, and then take the remaining two ends and hook them to a battery. So we can see that the bulbs do light. There is a current flowing. The current is not as strong, obviously, because the electrons are not moving as quickly, and the bulbs are not glowing as brightly. Okay. If we look at the current, before we had 0.9, now we have 0.45, and it is exactly half because we have two identical bulbs now where we had one, and those bulbs are in series. If I look at the voltage, the battery is going to provide 9 volts. One bulb will use 4.5. The other bulb will use 4.5. And if I look at both bulbs in combination, they use 9, because everything supplied by the battery has to be used by whatever's in the circuit. Current-wise, 0.45 everywhere. I think I did that, but just in case, there you go. What happens if I add another bulb? So let's put a third bulb in series and hook it up. All lit, all much dimmer again. 0.3 everywhere. 9-volt battery, and one light bulb is 3 volts. The next light bulb is, I didn't quite get there, also 3 volts. The last light bulb, should be no surprise, is also 3 volts. Moving these things out of the way. Let's now line up in parallel. So here is my light bulb. Here is my second light bulb. To light them in parallel, I want to connect two sides of the light bulbs together, and then the other two sides of the light bulb together, and then connect the two sides to the battery. There are multiple ways that you can draw this circuit or wire up this circuit. This is the one I chose to do now. So here they are. They are lit, and they look roughly the same brightness as our single bulb. If we look at current, the battery in this case is producing 1.8, but going through each bulb is only 0.9. At this junction point right here, the current splits and 0.9 goes through or comes from each bulb. If I look at voltage, the battery should still be a 9-volt battery, right? And each bulb is going to use 9 volts because each bulb has its own path to the battery. If I were to add a third bulb in parallel, I would still get a 9-volt usage by that battery and 0.9 amps flowing through it, but the battery would have to supply, that'd be 2.7 amps, 0.9 times 3. One last thing I just want you to think about is I can put more than one bulb into a parallel branch. So for example, don't do that. I'm going to open this parallel branch up, put another light bulb in, and I'm going to wire it in series with the other one. So now I have this one, which gets 0.9 amps because it has its line to the battery. The other two get less. You can see they're glowing less brightly. They're at 0.45 amps, which is what we saw when we had just 2 bulbs in series without the parallel combination. And the battery has to produce both 0.9 and 0.45, which is 1.35. The bulb that has its own path has to use all 9 volts. The 2 bulbs that are in series have to use 5 volts each, or 4.5 volts each, sorry, not 5, so that the combination is 9 volts.